Right, this is the Professional 2 page, and we go into much finer detail now about the gyro operation. An important part of the gyro is the Kalman filtering. There's a Kalman filter for each of the axes. The Kalman filter is a very good filter for actually eking out the correct rate data that the gyro is trying to measure. Of course, with any measurement system, there's noise associated with the measurement, and so the Kalman filter tries to pick out the true value irrespective of the noise, and it achieves this with very little delay compared to other filtering systems. So each axis can be configured slightly differently. We have 3 values that can be input here. One is the measurement noise. So this is a noise associated with measuring the data, and if you have a very noisy environment, then this can be increased. Here we have acceleration noise. This is noise created by the aircraft itself. It may be poorly designed aerodynamics on the aircraft, or some control surfaces which have problems with them, and so this can also be set sort of to describe more accurately the aircraft. We also have an inertial mass section here. This has an effect because the Kalman filtering itself uses a physical model of the aircraft. So if you enter more accurately the weight of the aircraft, then this physical model will be a little bit more accurate, and so allow the filter to operate just that little bit better. Now these filters can be enabled or disabled should you desire, but there's also here a predictive mode which by default is enabled, but for quadrotor applications it should be disabled, and it is in fact internally to the gyro automatically disabled if the eye adjust or heading lock feature is used. Now the predictive mode feature allows for the physical model used in the Kalman filter to actually use the actual input of the actual roll rate required. So if you want to do a high pitch movement, you will input to the gyro that you want a high rate on the pitch, and that information will be used by the Kalman filter to more accurately predict the next pitch measurement it has to make. Depending on the noise environment, it's also possible here to change the high-pass filter cutoff frequency. The options here will change depending on the output data rate. It's also possible to do data averaging here over a number of samples. It's not really advisable unless it's an extremely noisy environment with motors running and various things going on, because the averaging filter will cause a delay in the gyro, between the gyro measuring something and the control signal going out to the control surfaces to counteract that measurement. So if you're going to change this, then I would suggest only to change it up to a maximum of about 8 or 9 or 10 samples. The fine zero calibration is a function that when you first put power onto the gyro in auto calibration mode, it will then automatically calibrate itself so that to the 0 level. This means that whenever you put the gyro, switch the gyro on, the aircraft should be totally stationary. This is the best way to achieve really good results and have a gyro set to absolutely 0 when it's motionless. Now you can set this up by yourself. If you take off the auto calibration, then the gyro will switch on more or less immediately. The auto calibration takes some 6 or 7 or 8 seconds to operate. So you can set this manually yourself. One way to do that is to go to the live data page have a look at the raw data coming from the gyro. You can look at it in a continuous mode, and you can see with the auto scale tick on, here the gyro is between -2 and +2. The raw data is pretty much centralized, so in this example there's no real need to do any adjustment. You can look at the Y data, and okay, this may be down just a touch, but if you look at the range here, it's a small range. And the Z data, well, the Z data is also pretty much centralized. So with this particular gyro, the factory calibration is pretty good, so there's not really any need to modify anything manually. But it may be necessary as time goes on to keep an eye on it and see if anything needs changing. But I would suggest to keep this on auto-fine calibration, so that you can be guaranteed that each time the gyro is switched on, it will automatically calibrate itself.